Hello, chemistry students. My name is Radu, and I will be explaining how to do spectroscopy on the computer. So, I have my Spectroscopy thing right here, and I've just connected that to the computer and turned on Logger Pro, which you all should have. And it should come up, once this is connected, this wavelength and absorbance graph. So, the first step is to calibrate your spectrometer. The first step to do this, you must get out a cuvette, fill it about 3/4 of the way with distilled water, and place it in. Make sure the clear sides are where the light's going through. See? Alright, so if you'll come into this computer here, under Experiment and Calibrate, you will see the spectrometer that we are using. So we're going to use that. So we're going to have to wait for it to warm up, but we're going to skip it because we're pretty badass. And
you can't say badass in your thing.
Oh, you can. Why did you just curse my video, Nalini? Alright, so we're going to finish calibration. And that'll just let us run through this. When you see it's about done, you click OK. Boom, things calibrated. Alright, so now that we've calibrated our cuvette with distilled water, we're going to put our solutions in. So, let's get rid of distilled water, and we'll do this greenish solution that you kind of see might have exploded on me because I was being stupid. So don't be stupid. So, fill it, the cuvette, with solution, cap, shake, 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 and pour it out. And we'll do that one more time. Eric over there, going to Princeton.
No, don't film that.
Alright, and now, since we rinsed it out twice, we'll fill this up 3/4 of the way full. And cap it. Use one of our handy dandy Chem wipes to get all the liquid off and make sure the two sides are clean. That's gonna be going through the machine. And put that in. So now you see we put it in. Clear edges go with the light. Now we're gonna collect. And well, boom! That is our absorbance at different wavelengths for this solution. So, now we've done one solution, we will do one more. So, click stop. And same thing, rinse out the cuvette. This is a kind of rose-colored solution. Kind of ran out of red food coloring. Sorry.
So, I wouldn't listen to Radu. He usually messes everything up.
This is take 2.
Amanda, I forget, who's the star of our play?
The stepfather, my character.
I believe it was mine. I believe I had the emotional soliloquy.
You hugged a cactus.
Shut up! Alright, nope, that's a little bit too much. It's a bit too little. Alright, so you can see this is our, it's not very colored. It just has a little bit of food coloring in it, but we'll see what we get. So, handy dandy Chem wipe. Clear edges.
You studied a lot then.
No, I really did. This
Like junior year and stuff. Like maybe
Clear
not this
edges.
year, but like,
And
yeah.
we'll collect again.
Like I was definitely say last year,
And we'll start the latest one so we can compare.
Like I was like a good amount. Like,
And you can see that this different color is mostly distilled water and red food coloring. You can see that the absorbance spectra is different as opposed to the other one. Alright? And one more for fun. We'll combine these two solutions and we'll see which one it looks more like. Now, if you had to guess, which one would it be more like? That's right. It's probably going to be more like the green one because there was not much red food coloring used. So, last one. You know the drill. Alright. So, let's fill it up. Chem wipe.
Yeah.
And put it in.
You're enjoying rubbing that a lot.
Hey, I have an idiot behind the camera. Don't pay attention to him. All right, so Look at that. It's almost exactly like the green one. And we'll adjust this graph because you see we're not really getting absorbance as much past, maybe 0.3. Not even 0.3. Like, some competitors over there, they know their video sucks, but that's okay. So you can see this red line. It was the kind of rose-colored one, which makes sense. And you can see that there's actually two lines here, the green one and a bluish black one, and they're about the same because we had a lot of green and not that much red. So you can see that's kind of close to this. And yeah, that's basically all you really have to do. There's one thing we can do to apply with our data. So as you can see, if you come over here next to the computer, we have peak absorbances at different wavelengths. And they're actually mostly lined up. You can see it's somewhere between 600 and 700. So we want to find what these peak absorbances, what their corresponding wavelengths are. So we will highlight all the area in which these two reach their peaks. You go over here to Analyze, to Statistics. And we'll do all 3 runs that we did. So for our first run, up here, you can see that our max absorbance occurred at 656.4 nanometers. For run 2, it was also 656.4. And our max this one was 656.4. So you can see that the maximum absorbance was caused by a common wavelength. Isn't that interesting? Alright? So you can do a variety of lab procedures with this data. So this has just been a quick run through on how to find absorbances using different types of solutions. So remember, after you're all done, you can save your data, you can print out whatever, and unplug your instrument. Make sure you clean out your cuvette. Any solution, you really want to make sure this is washed well, because this has to be very clean in order for it to be used again.
She was older than us. Never mind, that's a different Sasha. She was like a couple years older.
So, put everything back in skates, put it away, and that is how you use spectroscope.